Hello, everybody. My name is Nevin. I'm filling in for my colleague Angela, who's not here today, unfortunately. Welcome to the next workshop for the EigenLayer Hackathon with Encode Club. Today's workshop is being held by Amrit Kumar from AltLayer, who will be talking about exploring Restaked Rollups with AltLayer. Hi, Amrit, welcome to the stage. Feel free to share your screen whenever you're ready and kick off the workshop.
So hello, everyone. My name is Amrit Kumar, and I handle operations at AltLayer. Previously, I was building a blockchain protocol called Zilliqa. And so I come from an academic background, and today's session is not going to be a hands-on session because what we build is not necessarily something that we can cover in a hands-on manner. So it's more going to be a presentation style where I'm going to take you through some slides that I prepared to give you a sense of what we do at AltLayer and how you can benefit if you're building either in the AVS space or if you're building a dApp and want to use any of the AVSs that we build. This would be the right, I guess, the first intro to what AltLayer does and what AltLayer can offer you. So we are known for this new idea that we call Restaked Rollups. And this presentation is mostly going to talk about what Restaked Rollups are, why did we start to build it, and how you can actually use these services. So rollups have become the new smart contracts, right? So previously, when you used to do, let's say, build a dApp, the first thing what you did was to write a smart contract. And essentially, all the rollups, the way they operate is through a smart contract. So essentially, rollups have become smart contracts. So you deploy a bunch of contracts on Ethereum, and that essentially helps you operate as a rollup. And so this has become even easier through the launch of different stacks like OP Stack, Arbitrum Orbit, Polygon CDK. So it has literally become like anyone can basically take that stack and deploy those contracts on Ethereum, and you have a fully operational rollup functioning on Ethereum. What has also happened is since the launch of OP Stack and some of the other stacks that are out there, people are building these services that are called RAS, so rollup as a service. So AltLayer is one of the RAS providers as well. And what they do is they take care of all your node infrastructure. So even if you have these rollups as a contract, you still need, let's say, a bunch of nodes like sequencer, or RPC endpoint. You still need to host the Explorer and bridges and whatnot. And so RAS providers are the one basically taking care of that for you. So now you could basically outsource all of that node management, infrastructure management to a RAS vendor, and the RAS vendor will run that for you. And you would then focus on building, let's say, the dApp. So our belief and our thesis is that by end of 2024, you will have thousands or more rollups being deployed on different chains. Now, in a world where you have hundreds and thousands of rollups, there are certain issues that becomes more prominent across rollups, right? So one of the main problem is this point that most rollups, when they operate with a single sequencer. So even every major rollup today, like Optimism mainnet, Arbitrum mainnet, they all operate with a single sequencer. Running a single sequencer does not have security issues, but it does have short-term liveness issues. So for example, if the sequencer goes down, you may not be able to transact directly on that rollup. Right? It's also possible that a sequencer may become malicious and start to censor transactions because it may not like, let's say, a transaction that goes to a certain dApp, for example, on that rollup. And so there could be censorship issues if you have a single sequencer operating your rollup. That is kind of okay if you're using, let's say, OP mainnet or Arbitrum 1, because the sequencer is kind of trusted because it's run by the foundation itself. But you cannot extend that trust, the sequencer trust that you have on OP mainnet, to a rollup that is using OP Stack. Because you could have an anonymous person or an anonymous developer launching a rollup, and then basically that has made some changes to the contracts, and those changes are so obscure that it's very hard to find it, and then eventually this sequencer or this rollup can rug you, right? So what I'm basically saying that you may trust a single sequencer as long as the single sequence is being run by a foundation that you trust. But you cannot extend that trust model to, let's say, a long tail of dApp rollups that would come up in the next 6 to 6 months to a year. The other thing is that most of these rollups today, they operate with certain kinds of training wheels. For example, OP stack does not have fraud proofs enabled today. Arbitrum 1 does not have, it does have fraud proofs, but the ability to challenge a node, if you want to challenge a node, you have to be in the whitelist. And they're working on it, but it's not currently live yet, where anyone can go and become a challenger. Now, again, because you trust OP mainnet, because you trust the foundations, you are kind of okay with these, training wheels. But that won't work very well with long tail of dApps. So essentially, what I'm saying is that rollups are not perfect today, and you want certain features and certain measures around these rollups that are decentralized and secure that can help your rollups, that can help these long tail of rollups to be much more trustworthy. And so this is where Restaked Rollups comes, right? But before I tell you what Restaked Rollup is, let me tell you what it is not, right? So Restaked Rollup is not a new rollup stack. So if you're familiar with OP stack, Arbitrum Orbit, it's not a stack of its own, right? It's not a rollup itself. So it's not a rollup like OP mainnet, like Arbitrum 1. It's also not a new way to secure rollup, right? So for example, we know that there are two ways, generally speaking, two ways that people build rollups. One is like optimistic rollup, and the other one is ZK rollup. It's not a new third kind of way to build a rollup, right? So what it is exactly a restaked rollup? It's essentially a modular framework that takes a rollup stack and brings certain kinds of tooling infrastructure around that rollup that makes the rollup better in many ways. So it makes the better rollup, let's say, more secure. It makes the rollup offer better decentralization, and so on and so forth. And it does this by bringing restaking to rollups, right? So let me tell you how that works, essentially. So at AltLayer, we're building this restaked rollup as an umbrella framework. And under this umbrella, you have three different AVSs. So three different networks that would bring restaking to these rollups. Mind you, each of these three AVSs are attached to a single rollup. You could have, for example, a shared model where these AVSs are shared across different rollups, but we believe that there would be scenarios where each rollup would have its own individual AVSs. So basically, the three AVSs, the first one is called Squad, which is for decentralized sequencing. As I mentioned earlier, most rollups operate with a centralized sequencer, and Squad, as a decentralized sequencing AVS, would help these rollups become more decentralized. The second AVS is called Vital. Vital is a decentralized network that acts as a challenger network for optimistic rollups. As I said, if you want an optimistic rollup to be secure, you have to have a bunch of nodes making sure that the sequencer and the one that's executing those transactions are behaving properly. And Vital is basically that network that keeps an eye on the proper functioning of the rollup. And the last one is Mach, which is a fast finality layer, which makes sure that you get a better latency and fast latency from a rollup that you're building. So at a high level, how this works, so you as a user or anyone that holds ETH will delegate their stake to certain operators, and those operators will then be tasked to run one of these AVSs, so Vital, Mach, or Squad. So out of these three AVSs, we are at the moment focusing mostly on Mach, and Vital and Squad is still being built. So what I'm going to do is I'm going to give you a high-level overview of what Squad is and how Squad works and how Vital works, and I'll give you a longer, I guess, description of how Mach works in practice, because it's something that is already live today on EigenLayer mainnet. So let's start with Squad. So as I said, we want to avoid centralized sequencing, because centralized sequencing creates single point of failure. If your sequencer goes down, then you may not be able to send transactions quite easily. It also involves or eliminates all sorts of censorship if you have decentralized sequencing. So even if one node is designed to be OFAC compliant, other nodes might be more open to taking that risk, and you could still take transactions that are violate OFAC in one way or the other. And it also allows your network to be more decentralized, right? So it allows, once you can run more sequencers, then you can invite community participants to come and get involved as a sequencer. So it also builds kind of your network and your community, and get your community involved with your network, which is otherwise not possible if you're just running a single sequencer. So the way it works is you as a user, you send your transactions to, instead of sending it to a single sequencer, now you'd send to a squad, this network. And this network would then order transactions based on certain sequencing policy. And you could say, hey, I want first come, first serve policy. The squad will then implement that policy for you and then would order those transactions according to that sequencing policy. And then that ordered set of transactions will go to a rollup executor, which could be, for example, a RAS vendor. And then the RAS vendor running the executor will then execute those transactions and then commit the final state of the rollup on Ethereum. So very simple and very straightforward. The second part is vital. As I said, it's a network for decentralized challenging and decentralized proving. So you could imagine, let's say you are running an OP rollup or optimistic rollup. You want to make sure that whoever is running a sequencer, centralized or decentralized, you want to make sure that the final committed state on the rollup is actually a valid state, right? And valid state, which is the result of executing a set of transactions starting from a previous state. And so Vital is basically that network that verifies things for you and makes sure that if something goes wrong, then there's a network of nodes that can go and challenge the sequencer and make sure that the sequencer and whoever is executing those transactions are kept accountable, right? And if not, then the sequencer or executor will get slashed, for example. And the third part is, as I said, Mach and Squad and Vital is something that we're still building. It's not fully ready yet, but Mach is one. The fast finality layer is the one that is already built, and we have already live networks currently on EigenLayer mainnet. So I'll spend a little bit more time on Mach, because you can literally go and use it today. So Mach is a fast finality layer. So basically, what it does is it takes transactions that comes from a sequencer, whether centralized or decentralized, and then we checks whether the rollups operators are actually behaving correctly according to a certain state transition function. So why do we need Mach, right? As it says, it's about fast finality, right? But let's talk about finality, from an Ethereum perspective. So if you're running a rollup, you usually send transactions or your state onto Ethereum, and the Ethereum network then locks that into the smart contract. And then if there's a challenge, then it can be challenged. But essentially, your state and your transactions have to go on Ethereum, right? And so from a rollup perspective, your transaction is not finalized until that state or those set of transactions are finalized on Ethereum. But currently, Ethereum does not have single sort finality. So when a validator proposes a set of transactions, they do not get finalized immediately after that. So in fact, it takes 2 epochs for a block to be, or a set of transactions to be finalized. And 2 epochs is roughly equivalent to about 12 minutes. So what I'm saying is, if you're sending transactions to roll up today, you have to wait until Ethereum has finalized your transactions, and that can take up to 12 minutes. And that's not ideal. Because imagine you're building a fully on-chain game on your rollup, and you want to move your transaction, your game logic forward. So you want to make sure that players are actually moving forward in the game. You can't do that unless you can make sure that the transaction and state that have been generated are actually finalized on Ethereum. Because if Ethereum rejects those blocks, you'll have to basically revert it back, right? Your state on the rollup. So you have to wait, ideally, for those transactions to be finalized on Ethereum. And so what most people do, or most dApps do, is they rely on the sequencer. They say, look, I'm waiting for transactions to be finalized on Ethereum is great, but it takes quite a long time, right? And so what we want to do is, or the alternative is to basically rely on the sequencer, right? Because sequencer takes your transaction and gives you a confirmation that, hey, I've seen your transaction at some point in the future. I will take those transactions and I will put that on Ethereum. Take my word for it, but here is my guarantee. The problem with this guarantee is, the good thing about this guarantee is it can be very fast, right? So as soon as you send your transactions and as soon as it reaches, the sequencer can commit to an ordering very quickly. So it can be, let's say, less than a second, for example. So it's very fast, but it's quite it's not confirmed. Like your sequencer can basically stop and put those transactions on Ethereum. So that promise does not have any economic backing behind it, right? And so so you either have to rely on Ethereum purely, you get slow, but you get hard confirmation. And on the hand, you can rely on sequencer to get fast, but they don't have any economic guarantee. And this is where Mach comes in. So Mach gets combined with EigenLayer's restaking mechanism, and through EigenLayer's restaking mechanism, it brings that economic backing, and then Mach gives you the faster finality, which also has economic backing behind it. So this is where Mach sits in the finality and economic backing trade-off space. So here's a base design of a fast finality layer like Mach. So a sequencer will take transactions. It could be centralized or decentralized, doesn't matter. It will take transactions from the sequencer, and those transactions and the state will go to the Mach network. The Mach network will then verify, if the state looks good to it, and then would pass data and the state to Ethereum. So you still are getting the finality from Ethereum if you wanted to wait for it. But if you want a faster one with economic backing, then the Mach network can do that for you. And once you have this fast finality from Mach, you can actually use that to build interoperability as well. So imagine you have two rollups, rollup A and rollup B. They're both attached to Mach, which is the fast finality layer. Now you have a transaction, a cross rollup transaction saying, let's say, I'm locking my assets on rollup A, and I want to mint some assets on rollup B. So kind of wrap, lock, and mint style transactions. If you want to do that, then your transaction will go to rollup A, and the rollup A sequencer will process your transactions, will produce a commitment to the state, and will push that back to Mach, and Mach would verify if that state commitment and looks good corresponding to those transactions. And then it would pass this confirmation to the rollup B, and rollup B would then see, hey, Mach has verified that this lock transaction has indeed happened and indeed been committed on rollup A. And so let me take that and now allow a mint transaction to happen on rollup B. So this way, Mach gives an attestation of a valid transaction on rollup A to rollup B. So in terms of restaking, whether restaking comes in picture, so obviously, as I said, Mach is run by operators, and those operators have to bring economic collateral. And what we want to do is this collateral that comes to operators could come from 3 different tokens. So it could be from ETH and STETH. So this is where the restaking part comes into existence. So now people who hold ETH can delegate their assets to the operator, and then that would contribute to security. You could have a dApp token. So imagine you are building a rollup and you want to use Mach. Your rollup may have a dApp token, and that token can also be staked. And then all token that we also have could also be used for staking. And then eventually all these operators that stake would get different incentives. So just by putting ETH, you're getting the staking and restaking yield. You can potentially get reward from dApp token, and you could also get reward from all token. So technical benefits of Mach. So as I said, the first one is it gives you faster finality. It gives you finality that can be achieved within 10 seconds, for example. So much faster than what you get from Ethereum. Note that it doesn't give you the same security as Ethereum, because Ethereum has a much larger, let's say, economic collateral securing it, but it at least gives you much stronger security guarantee compared to what a sequencer gives you today, which has almost zero security guarantee. As I said, you can use Mach for interoperability across different rollups, and this can be used in different ways. So imagine you are building a bridge, you're a third-party bridge builder. You could use the attestation from Mach as a confirmation to, let's say, allow people to instantly withdraw from a rollup if you have liquidity on that bridge, right? So imagine all sorts of liquidity-style bridges where the bridge basically today is running their own full node. They don't have to run that anymore because they could tap into Mach, because Mach already does that for you. So the different modes in which Mach can operate, there's a pessimistic mode. This is the one that's most popular, or I would say the one that we are running at the moment today, where basically the Mach nodes run as a full node, and they check, rerunning the transactions if the network if the rollup is operating correctly. And if that's the case, then they would give attestation for that rollup block. It's the simplest, but not the most efficient, because basically you're redoing the whole computation yourself as an operator, and that's not ideal. The second mode is an optimistic mode, where basically the Mach network assumes everything is valid and correct, and then there's a challenger network like Vital sitting behind Mach, and Mach would then say, hey, this Vital would then say, hey, look, I have detected malicious behavior, invalid block state, and then they would do a challenge around that. So it could also be an optimistic mode where you're not running full node, but basically running kind of full node, but you're not executing every transaction yourself. But you have challenger network basically challenging on top of that. You could also have a validity proof model where Mach network would ask a sequencer to, let's say, periodically generate proofs for the blocks, and those proofs will then get verified on Mach, and then that gives you the validity that you need. So I'm coming towards the end of my presentation. And so there are three ways in which you can get involved. One is if you are, let's say, a staker, or if you want to get involved as a restaker, come and look at stake.altlayer.io. If you are a dApp builder and you're thinking about having a rollup, or if you're building and want to come to us and talk to us which stack to use, how to get restaking involved, you can go to our docs, or you can even come to talk to us, and we'll help you guide through this restaking journey or rollup journey. Also, finally, if you're AVS builders, if you're building any sort of AVSs, it's quite likely that your AVS will, our rollups will benefit from what you're building as an AVS. So come and talk to us, because we are essentially one of the biggest distribution providers for many of the third-party services. So if you're thinking of building an AVS and want users towards your AVS, come and talk to us. We'd love to connect and chat and how our rollups can benefit from what you're building. Well, that's it for now. Thank you very much.
Cool. Let's then shift over to a short Q&A. Feel free to pop any questions you have in the chat, guys. And in the meanwhile, I'll start off with a question of my own. You mentioned that you were still building Squad and Vital. Do you have any ETA of when that could possibly be ready?
Yeah, so the reason why we're still building it is because it, unlike Mach, which does not need to, it doesn't need to be integrated directly with a rollup. It's more of a kind of sidecar thing. Vital and Squad needs to work very closely with a stack, and all the stacks today, OP stack, Arbitrum, they're changing quite rapidly. So if you do that today, or if you build that fully entirely today, it's most likely not going to work tomorrow when the new release comes up. So I would say it's somewhat dependent on when those stacks get fully mature. So I would say 4 to 5 months.
Yeah. Okay. Awesome. Any question, guys? Now is the time to ask. Tomorrow will be too late. In the meanwhile, where can people reach you, Kumar? I guess on Twitter or on Telegram, or would you mind sharing some of your socials?
Yeah, of course. So you can go to Twitter. It's alt_layer. We are also very active on Discord. And just ping us, on Telegram, on Twitter. If you DM us, we definitely would put you in touch with the right team members who can help you get started. So either as a builder building dApp, or anyone who wants to, let's say, get restaking into their AVS, we would love to have support you anyway.
Yeah. Cool. Looks like we have a couple of questions. First up, are you working or integrating with any RPC providers?
So we work with, 10, 15 RPC providers. So mainly because we also have this RAS service. So we build and manage rollups for clients, and many of the clients actually need different kinds of RPC. They have requests for RPC providers. So we actually do work with many RPC providers. We're also working with Infura has recently built a thing called DIN, decentralized Infura network, if I recall correctly. And this is basically a decentralized RPC network. So we also, we do integrate with RPC providers. So if you're building one, come and talk to us.
Cool. Anybody who's working with AltLayer for Hackathon project, what kind of a project would you like to see built with AltLayer?
So I would say for us, we unlike some of the other, let's say, L1s, L2s, or things where basically you're building on that, we ask you to build using other stacks. So for example, if you're building a dApp, for us to be in the picture, you have to build a rollup, essentially. It cannot just be a dApp. So you have to build a rollup. So if you're building, let's say, on a perp exchange, you have to, let's say, pick a stack like OP stack, Arbitrum, Orbit, Polygon CDK, and use that to have a rollup. And once you have that rollup, either we would help you run that rollup, or we would help you with restaking. So you don't build directly on us. You build, if that makes sense, you build using one of the stacks, and then we become your partner in your restaking journey.
Yeah, makes sense. Looks like somebody's typing in the chat, so let's give it a second. What rollup provider would you recommend?
I would say there are different pros and cons to all the stacks. So OP stack is, I would say, the most OP Stack and Arbitrum Orbit are the most stable one at the moment, but they're optimistic in nature. So if you don't like optimistic rollups, you should go towards let's say Polygon CDK or some of the others. There are other caveats as well. So for example, OP Stack is working at the moment on bringing native gas token as well. So for example, if you have your own DApp token, if you want to use that DApp token as a gas token in your rollup, you can't do that today on mainnet, but you can do that with Arbitrum Orbit. So there are pros and cons to different stacks depending on which what your preference is and what sort of changes you want to make to your rollup to suit your needs.
Cool. There's another question from James. Thank you, James, for all the questions. They're very good. How do you choose between a superchain versus EigenLayer without, I assume, liquidity?
With respect to
yeah.
Okay, with liquidity fragmentation. So I would say superchain is still very early. They are still building things around how liquidity will be shared across different superchain chains. EigenLayer in a similar state, which is still building in a different ways. But my feeling is superchain is a much bigger concept than EigenLayer. It's not just about liquidity fragmentation. It's a lot more superchain, right? For example, you could have sequencing in superchain, a common sequencing layer in superchain. EigenLayer is mostly about giving people interop or giving people a way to access liquidity across. So I would say EigenLayer is much more focused on liquidity, while superchain is a little bit more abstract, and liquidity fragmentation. Liquidity is one part of superchain.
None is asking what are dApps like Burps can be created which can benefit with its own rollups.
So I would say the first wave of projects that were building building their own rollup were mostly projects they were building around the gaming ecosystem. So people building fully on-chain games, they were the first adopters of rollups. Over time, we have seen quite a different story. So over time, we have seen people building dApps so I would say a dApp that can stand on its own. So let's say if you take Uniswap as example, Uniswap is really not a good example to be on its own rollup because you want to enjoy composability. And at the moment, if you're building on a rollup yourself, the composability is not the best, it's not best there. So I would say if you're building a dApp that does not require too much of composability, then I think you should go and build your own rollup. Socials are a really good example because do not require too much of composability, and it can drive a huge volume of transactions. So if you need scalability, huge scalability and latency, you should go for a rollup as well.
Yeah, Katya is actually asking how can we reach you on Discord. Yeah, I think.
So I'll write my. So this is me on Discord. But I mean, I'm mostly active on Twitter. So if you ping me on Twitter, that works as well.
Yeah, cool. One more question from James. Have you seen any projects using AltLayer to empower intent-based networks?
We haven't. We were speaking with a client that was building an intent-based rollup, but I don't think we have signed them quite yet. But yeah, we have seen people building intent-based rollups and who have come to us and talked to us. So the answer is yes.
Looks like that's it. If there are no more questions, I think we can slowly wrap it up. Once again, thank you very much, Kumar, for coming in and holding the presentation on AltLayer, and thank you for everybody else. Thank you to everybody else for coming and for all of these wonderful questions. See you for the next workshop tomorrow.
Well, thank you very much, guys. Thank you very much for all your questions.
Bye bye.